Hello there, my name is 𝘂𝗵𝗶𝘀𝗀. In this short video, I'm going to show you how to construct a nominal yield curve using UnRisk for Excel and bond prices. Here's the curve construction example workbook which is provided with UnRisk. There are various tabs for constructing the curve and also for managing market input data, instruments and prices, and we'll look at some of those in a moment. But the curve construction task is shown on this sheet, and the task itself is actually under my cursor here on the right. Now, this task is very flexible. It can be used to obtain rates consistent with the bootstrapping algorithm over swap or other market instruments, or, as we'll show here, fit a curve to bond prices, bond yields, but with attention given to how smooth and flat that curve is. And this is very useful for constructing curves, as we will have here in the case of UK gilts, used for long-term asset and liability risk management. So let's review these inputs. On the left here, we have the fitting parameters, defining the weights to smoothness and flatness in compromise with the price, shown here on the left. And you can look at the documentation for more examples or more detail about what each of these things actually means. Then we have the metadata, a yield curve definition we've seen in other examples, defining the properties of the curve that will be built by the optimization algorithm. On the left, we have a list of UK gilts and their associated prices. I'll show you how we obtain these in a minute. Then we have a list of tenors. We're going up to 50 years here, for which we want to construct the curve. You could have monthly tenors here, or restrict yourself to not having just annual tenors, but maybe every 5 years, depends on your purposes. And then finally on the right, we have the task itself, which is constructed from reference date. And these four things, which I've just mentioned here on the left. And then we have the UnRisk.build_s command, which takes, as we've seen in other videos, the type of the entity to be constructed, the headers, and the values. And that returns an UnRisk object. Right, now I've hopped over to the fixed rate bond sheet. Here is a list of all the on-the-run UK nominal gilts and issuance on the valuation date, obtained from the DMO. And as you can see, as each is of the same type, fixed rate bond, we can create a table of instruments. Now on the right, we use the UnRisk build_s command to construct each object. Now it's a bit unpleasant to look at because it's using this Excel convention, but it really just follows the same pattern we've used elsewhere. So I use build_s, where I give it the type of the entity to be constructed with fixed rate bond, the headers shown here along the top, and then the values. And then using the table functionality in Excel, it just fills out the rows accordingly. One more thing, on the very far left, which is not part of the UnRisk build command, I've configured a key based on the ISIN of each of the instruments. And that's going to be useful because we're going to pair each of the instruments with the price next. Now I've hopped over to the prices sheet, and this is very simple. It's just an association of each instrument's ID, the key, based on its ISIN, type of clean price, the value, which I can get from market data, and I construct for each one of these guys the object of type price, just as we did in a previous video where I showed you how to price a fixed rate bond. Again, this just takes, it's just the UnRisk build_s command that we're familiar with now. It takes the type price, the kind of the price is clean price, and the value is given as such. And using Excel tables, it can drop that formula down throughout the table. Now let's head back to our curve construction sheet and start actually building the curve. Okay, now I'm back on my curve construction nominal sheet, and I've just done an association with lookups to get the right price associated with each of the bonds here. So I effectively have a portfolio of bonds, although I don't have any particular positions in each one. They're all treated with the same weight. And we mentioned earlier, we've constructed the task here, and this is a task that we can now solve with UnRisk. Now, something that's quite important, you shouldn't have automatic calculation turned on, okay? Don't really recommend using that for complex spreadsheets, and using UnRisk if you're doing complex calculations such as this one. This optimization procedure is going to take a little bit of time, of order half a minute to a minute. So don't have automatic calculation turned on. So to construct the curve, we say UnRisk.solve, give it the task, and let it think about it for a minute. Okay, we now have a successfully returned result. I just want to show you something before we expand that result and tell you what we're given back. If you click on the UnRisk pane, you've got the cell selected here, and you go to the Tools panel of the UnRisk add-in, you scroll down to the cell inspector, you'll see here the underlying JSON representation of the data that's been returned. If you collapse the various fields here, you'll see one called messages, where you see the output from the UnRisk engine, one of which will tell you how long it took the engine to complete this calculation, 33 seconds. It will depend entirely on your computer. In fact, I'm running UnRisk here on a virtual machine. And it will depend on how many bonds you have, how severe your fitting parameters are, and such like. It depends to what extent how noisy the market is as well. Inflation construction, which is also another example provided, takes longer. It's much more sophisticated. Well, it's a much more involved process. So there we go. What is the data we get back? Well, using the unrisk.expand command, we can unpack the results, and we get a goodness of fit object and a yield curve. And if I expand the goodness of fit, again using expand, but I choose it to be fully expanded, in other words, take out all the objects and expand them fully in Excel here, you can see things such as the optimized price, the difference with the given price, the original price here, the weight that each of the bond has, because actually this fitting procedure weights bonds towards the short end of the curve more than the long end, but you can experiment with the parameters. Do look at the documentation. But for example, a pricing error and a weighted price difference to give you a measure of how close the curve is to each of the bond prices expressed as yields. If I then take the yield curve and I unpack it, you'll get what we've all been waiting for, which is the rates and the tenors that we asked it to fit for, and we get this curve here. Now this curve seems to have quite a lot of structure to it. This is a spot curve, so it's already implicitly smoothed. If I looked at this in forward space, I think this would be quite noisy. However, I have set here that my parameters for flatness and smoothness are 10 and 10, which from bitter experience I can tell you are very low. So it will give you a very tight fit in terms of bond prices, but not really a very good curve, certainly in forward space, for asset and liability risk management. On the right here is one I did earlier, where I used settings of smoothness and flatness of 500 for each of those parameters, which are quite good for the UK market. And you can see we get a much smoother curve, and we're going to have much more well-behaved forwards. So you can see readily in Excel that actually all you have to do now is go and change this parameter here, hit recalculate, get a different result, and then you can find the parameters that fit you. It will depend on your purposes and what you want to do, but it's a very convenient way, as you can imagine, to work with UnRisk through Excel this way, and then you can obviously show your colleagues who might be working from a systems development perspective how to integrate this into a daily running procedure in a system using C#, whatever environment they like to develop systems around UnRisk in. Right, so there we go. You'll find this example distributed with UnRisk, so you can experiment with it yourself. In the same workbook, you can see the example for constructing an inflation curve for inflation-linked gilt prices using the constructed nominal curve as input for discounting. We also looked at how you can use standard practices in Excel so that working in Excel is still normal. Indeed, this example used the tables functionality. To be honest, this isn't my preferred way of working. I find the newer dynamic array formula and Xmatch and so on much more flexible. It's up to you. In any case, it's a very convenient environment for many financial users to work with UnRisk, and the underlying JSON representation and program model mean that you can then hand such a workbook to system programmers to replicate and obtain the very same numbers when using UnRisk in another environment like Python or C#, and that really helps things. So on that note, you're ready to price your own bonds, construct your own curves, and your own workflows. Thanks for watching.